All right, let's dive right into this explainer. We're going to unpack the intricate, highly stylized C99 codebase of Best Imagined Destiny. You know, if you've ever wondered how cold, hard code can literally give birth to a living, breathing digital ecosystem, well, you are in the exact right place. We're looking at the very bedrock of this project, the C99 fundamental, and we're going to see exactly how it orchestrates this wild symphony of logic, art, and network consensus. So, what actually happens when you mix rigid cryptographic math with creative algorithmic generation? Sounds like a total paradox, right? I mean, cryptography is usually all about hiding information and locking things down, while generative art is about infinite expression and visual freedom. But here, in Best Imagined Destiny, these two forces aren't fighting each other at all. They are literally dancing together. To wrap our heads around how they dance, we really need to understand the core philosophy. This codebase is what's called a deterministic generative framework. Basically, that means every visual output, no matter how chaotic or organic it might look on the surface, is mathematically guaranteed under the hood. There is absolutely zero true randomness here, none. If you start with the exact same seed, the state machines and cryptographic hashes will grind through the exact same gears to produce the exact same digital artifact every single time. It is predictable chaos, engineered to absolute perfection.
Okay, here is the roadmap for our data journey today. 1. Primal math and hashes. 2. The fractal phi jewel. 3. Waking the permute dragon. 4. Emergence and Virum words. 5. The network hive federation. And finally, 6. Running the complete system.
All right, section 1, primal math and hashes, the foundation of determinism. So we start our factory tour right at the foundation. The system initially relies on a completely standard SHA-256 implementation to securely hash states. This acts as the secure bedrock for the whole framework. It's the exact same cryptographic standard used in massive global networks right now to secure data. In Best Imagined Destiny, this ensures that any input, no matter how tiny, creates an avalanche effect. It results in a wildly different, yet completely deterministic 256-bit footprint. But here's the catch. Why is this special? Well, if we just use standard hashes, things could get mathematically a bit too uniform, a bit too boring for an art project. So they introduce a custom module called HEXPHIBIN. This uses constants derived directly from the golden ratio phi to create totally unique, non-repeating fold values. This brilliantly illustrates how the creators injected a little bit of natural world magic, literally the math behind spiral galaxies and sunflower seeds, right into the C99 code. The math literally folds inputs using phi and inverse phi, ensuring the deterministic outputs actually feel organic and alive rather than artificially flat.
Moving on to section 2, the fractal phi jewel, the state machine.
The fractal phi jewel is essentially a graph-based state machine. Individual jewels are connected by edges with really strict mathematical constraints, like match, mismatch, or XOR. Think of this like, well, cryptographic clockwork. You define jewels, which hold a state, and connect them with rules. When the system ticks, it tries to apply a delta, or a change, to these jewels. But here's the kicker. The tick is only successful if every single constraint on the graph holds true. If node A and node B must match, and the delta breaks that rule, the tick is immediately rejected. It's just a beautiful self-regulating constraint solver written purely in C.
Section 3. Waking the permute dragon, the hashing engine.
Once the jewel ticks and generates a seed, it feeds it to an engine with the incredibly poetic name, the permute dragon. Now, what's really fascinating is how the permute dragon acts as a key derivation function. It swallows that massive standard hash we talked about and distills it down into a highly concentrated 16-bit word called a flame sigil. A 256-bit hash is incredibly secure, sure, but it's just way too unwieldy to map directly to visual traits. So the dragon's entire job is to chew up that massive string, securely shuffle the bytes around, and compress the whole shebang into just 16 golden bits.
By shuffling the inherited hash with our golden ratio math, we get these incredibly deterministic pseudo-random values. Actually, when you trace the loop in the code, you can see it folding the left and right sides of the SHA-256 digest using that HEXPHIBIN logic we just covered. By combining bit shifting with phi-based folding, the permute dragon essentially guarantees that every single bit of the final 16-bit flame sigil is deeply, deeply impacted by every bit of the original state.
Section 4. Emergence and Virum words decoding the output.
So the crucial point now is understanding how that tiny 16-bit flame sigil actually turns into generative art. Enter the emergence65k module.
It slices up that 16-bit word to extract precise aesthetic traits, dictating everything from a character's family and contour to its eyes, mouth, chroma, ornament, and pulse. Because 16 bits gives us exactly 65,536 possible combinations, the module uses bit masking to carefully carve up the word. The highest bits might dictate the family, while lower bits decide the chroma. There's even a single bit dedicated entirely to pulse, which is basically a binary toggle deciding if the generated entity is structurally static or if it's literally glowing with life.
It goes even further, computing specific blended RGB colors using dynamic weights. The code dynamically calculates these weights based on those exact same phi-derived folds, blending the base, accent, and glow colors together seamlessly. And hey, if that pulse bit is active, it actually boosts the luminosity of the entity's glow. This is the exact moment where cold numbers become warm, vivid aesthetics. And happening right alongside all of this, the VermWord module is busy parsing out actions, giving this aesthetic entity functional verbs and routing data so it actually knows how to behave.
Okay, Section 5. The Network Hive Federation, scaling the system.
All of this incredible data generation doesn't just happen in a vacuum. It broadcasts outward to a federated network, and the mathematical complexity absolutely peaks at this network scale. This consensus mechanism relies on a massive 144-dimensional collective vector. Every single node in this network isn't just saying hello, it's bringing its own complex math to the table. By taking that concentrated 16-bit micro-level output and averaging out vectors across a sprawling 144-dimensional space, the network achieves this highly complex, mathematically beautiful macro consensus.
These network nodes send cryptographically signed invites and compute global coherence, returning weighted deterministic receipts back to the Hive. To make sure the node invites are actually valid, the Federation explicitly checks the HMAC signatures. If a node gets accepted, its weight is added to the collective, and the entire network recalculates its global coherence. So what we're looking at is essentially a deterministic, decentralized brain made entirely of C99 code, continually balancing itself as brand new visual and functional entities are born and join the Hive.
Finally, Section 6. Running the complete system. The data journey complete.
Let's quickly look at the execution flow to see how this all builds together sequentially, right from start to finish. Just like we outlined. 1. The system initializes the kernel. 2. It ticks the state jewels. 3. It produces the flame sigil. 4. It decodes it and broadcasts the vector to the Federation. This is the entire heartbeat of Best Imagined Destiny. It starts by setting up the constraints, applies a change to test the math, compresses the success into a sigil, gives it a visual body, and then finally gives it a home in the network.
Looking at the actual C99 execution in the demo module, we can see exactly how the poetic structure anchors all of this dense, deterministic math into a logical, step-by-step life cycle. You see the kernel initialized, followed by adding the jewels and constraints. Then it kicks. Once successful, the dragon produces the flame, which cascades right down into emergence and VermWords. And finally, the network hive federates the results. Honestly, it is stunningly elegant code. There is zero bloat here. Just pure cascading logic that transforms a single cryptographic tick into a federated, colorful, multidimensional ecosystem.
So with such a rigid mathematical foundation, producing truly endless aesthetic possibilities, you really have to ask yourself what kind of system you would construct. When you strip away the chaos of total randomness and replace it with predictable, golden ratio-driven determinism, you aren't just making code anymore, you're architecting destiny. It leaves you wondering if every output is a guaranteed mathematical truth just waiting perfectly in the void to be discovered. What truths would you seek out to build your own universe? Keep exploring, and I'll catch you on the next explainer.
Hey everyone, welcome. I am absolutely thrilled to have you here for this explainer. Today we are going to unpack something truly fascinating. We're looking at an incredibly abstract, elegantly constructed C99 code base known as Best Imagined Destiny, or the C99 Fundamental. If you're a focused learner who loves seeing how complex, highly theoretical systems are built from the ground up, you are in the exact right place. We're going to explore how raw mathematics and cryptography give birth to a structured state machine, generate visual traits, and ultimately form a decentralized network. And the kicker? It's all written in classic hyper-efficient C code.
Okay, let's dive into this. Think of this next slide as our structural blueprint for our building block journey through the code. We'll be covering the cryptographic foundation, fractal phi dual logic, generating traits and outputs, the network hive federation, and finally, orchestrating the full system. So let's just get right into it.
Part 1. The cryptographic foundation. This is the very bottom layer of our system, the mathematical DNA, if you will.
Now you might be wondering, how do we create unpredictability here? Well, it doesn't just rely on standard random numbers. It introduces this concept called HEXPHIBIN. I know, right? It sounds literally like an ingredient for a wizard's potion, but it's actually a highly specific, beautifully elegant mathematical folding primitive. Instead of just standard math, HEXPHIBIN uses the golden ratio, represented as phi, as a multiplier for mixing inputs. By shifting and multiplying bits against fractional representations of phi, the system creates this beautifully chaotic, yet entirely deterministic, randomization engine. And this brilliantly illustrates how it all comes together. We have standard SHA-256 cryptographic hashing, acting as our rock-solid anchor of trust. You know, the exact same kind of math that secures modern networks. But then, that standard output feeds directly into the custom HEXPHIBIN folding function. That's where the golden ratio math folds those bytes together, generating our unique system DNA. It's a real game changer. Moving on to Part 2, Fractal Phi Joule Logic. This is where we transition to the brain of the organism, where that raw math becomes a structured state machine.
Within this C codebase, the core operational units are called joules. But, okay, don't let the name fool you. These aren't shiny gems for display. It's more like interactive nodes within a geometric state machine. They are the structural brain cells of the system, and they're constrained by strict topological rules. They actually talk to each other, they share states, and they have to obey very specific logical constraints to exist in harmony. And here's how that's enforced in the code. The FPJ_constraint_holds function acts as the ultimate referee for these joules. Before any state gets updated or a new tick of the system is finalized, this block of C code steps in to validate the interactions between the nodes. It ensures absolutely every connection follows our mathematical rules to a T.
So the crucial point here is how these constraints scale in complexity. On one hand, you have a simple direct match. An FPJ_A to match constraint just checks if a single isolated A bit matches between two connected joules. Pretty straightforward, right? But then look at the FPJ_XOR ABC constraint. That one requires a complex multi-bit XOR computation across all three active bits, A, B, and C, just to match perfectly. The system elegantly layers these really simple matches right alongside intricate interdependent logic puzzles.
All right, Part 3, generating traits and outputs. We're moving from the abstract state machine to the appearance of our system, where the code actually generates visual properties. The bridge between that mathematical brain we just talked about and the final visual output is this concept called the flame sigil 16. The codebase uses a module, creatively named permute dragon, which I love, to take the states of our joules and heavily compress them. The output, this flame sigil 16. It's a single unique 16-bit word that acts as a strict cryptographic fingerprint for the entire state of the organism at one specific moment in time.
Now, what's really interesting about this next breakdown is how densely packed this visual DNA actually is. This single 16-bit word is unpacked by a subsystem called emergence65k. And get this, just 16 bits determine literally everything. The family it belongs to, its contour, its eyes, mouth, chroma, ornamentation, and even a binary pulse state. It is an absolute masterclass in storing a vast array of visual possibilities in literally 2 bytes of data. And you can see how it perfectly maps out in the code. The E65k_from_word function makes this a reality using bitwise shifts. You know, shifting right by 14, by 12, by 9, all to meticulously unpack that 16-bit word. These bitwise operations dictate the base colors, the accents, the RGB color weights, bringing a digital entity to life entirely through raw binary masking. It's just brilliant.
Okay, shifting gears to Part 4, the Network Hive Federation. We have to ask, how do these visual nodes actually interact in a decentralized environment?
Well, the network_hive federation.c file sets up what is essentially an exclusive decentralized network club. It's definitely not a free-for-all where any node can just connect willy-nilly. It's a highly constrained social structure. It literally requires mathematically verified cryptographic invites just to participate. This ensures that only valid, proven nodes can influence the broader network.
Let's move to and see how this builds, stepping through the exact sequential life cycle of joining this network. First, an existing authority on the network runs NHF_issue_invite to generate a secure invitation.
Step 2, the aspiring node uses NHF sign node to cryptographically sign that it received the invite, presenting its current state. And finally, the network runs NHF_weighted verify emit to check the math and officially welcome the node into the federation. 1, 2, 3.
But trust me, that NHF weighted verify emit function, it is completely unforgiving. As you can see in the logic here, it recalculates the HMAX SHA-256 invite signature and compares it directly against what the node provided. If those signatures don't match, or say the invite was already used, or even if the node ID is wrong, boom, it immediately rejects the node and emits a failure receipt. There are zero shortcuts allowed in this society, for sure.
So, what happens once a node is actually accepted? It starts contributing to the Hive's collective consensus, which is tracked using an array of 144 dimensions, exactly 144. This is the fixed dimension of the collective coherence vector, defined as NHF_dim in the source code. Every valid node applies its specific weight and state to these 144 dimensions, allowing the decentralized federation to mathematically track its overall coherence and alignment. It's a massive, multi-dimensional balancing act.
Which brings us to our grand finale, Part 5, orchestrating the full system. This is where all these disparate building blocks are fused together.
It is just incredible to see this entire complex system boot up in just a few dozen lines of C code within the main function. We initialize the fractal kernel, generate the cryptographic hashes, unpack the visual emergence, and connect to the decentralized Hive federation, all right here on a single screen. It really is a masterpiece of compact structural orchestration.
So let's summarize that final execution path step by step. First up, we initialize the kernel. We add our 3 center jewels and define their edges, creating the brain structure. We tick the state machine, which triggers the DNA math to generate a seed text. Then we run the permute dragon to compress that into a 16-bit flame sigil 16. We push that sigil through emergence65k to generate our visual RGB traits. And finally, the node successfully issues a Hive invite, signs it, and joins the federation. The DNA created the brain generated the appearance, and the appearance joined the society.
And that brings us to the end of our explainer. But before we go, I want to leave you with a provocative thought. We've seen how elegant and remarkably strict the C99 codebase is at maintaining structural integrity and decentralized consensus. So, beyond abstract visualizations or digital art, what critical real-world systems could benefit from this exact blend of decentralized networking and geometric state generation? Are we talking about power grid management, autonomous vehicle swarms, secure financial consensus? The destiny of this code is limited only by what we can imagine. Thank you so much for diving into the C99 fundamental with me, and keep exploring.
Welcome to the Explainer. Today, we're taking a journey into decoding a complex, decentralized, procedurally generated universe. And get this, it's built entirely in C99. We are literally going to break down the DNA of a digital organism right here, right now.
Okay, let's dive into this. How do you actually build a decentralized, procedurally generated universe from scratch in C? I mean, the sheer ambition of the best imagined Destiny codebase is absolutely massive. We aren't just looking at random number generators here. We're looking at pure, raw, procedural generation, taking strict mathematical laws and using them to evolve an actual living digital system. So here's our pipeline blueprint for today. First, cryptography and phi math. Second, building fractal phi jewels. Third, forging the flame sigil. Fourth, visualizing with emergence65k. And finally, number 5, the Hive Federation network.
All right, part 1, cryptography and phi math, the laws of physics.
At the absolute bedrock of this universe is SHA-256. But actually, scratch that, instead of just securing data like you'd usually see, here it acts as the system's foundational DNA. Every single state change, every network invite in this ecosystem, it all relies entirely on this unalterable cryptography. It is the absolute, unquestionable source of truth for the entire organism.
Now notice how the codebase brilliantly introduces the golden ratio into the math. Over in the HEXPHIBIN.c file, the constants Q16 phi and Q16 phi inverse are quite literally the golden ratio and its inverse, just mapped into fixed-point arithmetic. The code uses these to mathematically fold data and hash values together. It's kind of like intertwining sacred geometry right alongside cryptographic entropy. It's just an incredibly elegant way to handle procedural generation.
Moving on to part 2, building fractal phi jewels, the core entities.
So this system evolves in a biological-like tick cycle, which is managed by the FPGA kernel. First, a mutation is proposed by applying deltas to the joule. Then, this system rigorously verifies the constraints between edges, and only if it passes all that does the new state actually commit. If it fails, the mutation is instantly rejected. No exceptions. This guarantees the joules safely evolve while maintaining total 100% structural coherence.
Now, what's really interesting about this is looking at the structural blueprints, the FPGA joule and FPGA topology definitions. They are completely bound by the rigorous constraint logic working right alongside them, like FPGA A-match and FPGA bridge. Essentially, two joules connected by an edge absolutely must obey their mathematical relationship. If they don't, the FPGA tick function throws an error and rolls back the whole attempt to protect the organism.
Which brings us to Part 3, Forging the Flame Sigil, Irreversible Transformation.
Look at the sheer scale of the data compression happening here. I mean, we start with the sprawling, massive state of the FPGA kernel. It holds up to 64 joules, 128 edges, plus various tracking counters. It's a lot of data. But then, all of that sprawling complexity is compressed down to a single, highly dense 16-bit word called FlameSigil16. This tiny word holds the entire lineage of the network state. And that compression is absolutely vital for keeping the system decentralized and lightweight.
So how does that happen? Well, this massive compression runs through the Permute Dragon pipeline. It takes the SHA-256 hash, shuffles it violently using that golden ratio math we talked about, and mathematically folds it over 8 distinct passes until it's locked into that tiny 16-bit state. It's basically a one-way trip that permanently etches the organism's history.
All right, Part 4. Visualizing with emergence65k, expressing physical traits.
And this brilliantly illustrates how it hacks almost exactly like genetic transcription. The system literally slices those 16 bits to dictate physical contours and colors. For example, bits 14 and 15 determine the family, while bits further down control the eyes, the mouth, and even the pulse. The code blends RGB color values based on weights derived purely from these bits. It's literally bringing the math to life right before our eyes.
65,536. Think about that for a second. That is the exact number of distinct visual states born from just that single 16-bit flame sigil. It's a stunning amount of decentralized variety generated from pure math, which means you're getting massive ecosystem-level complexity with virtually zero overhead. It's honestly mind-blowing.
Which leads us to Part 5, the High Federation Network, Achieving Coherence. Zooming out a bit, for a newly formed node to securely join the hive, it really has to prove itself. First, it initializes with its traits and a massive 144-dimension vector. An invite is then issued and hashed with a secret. Next, the node signs itself via HMAC SHA-256, and only after all that does the Federation verify the signature and actually emit a receipt. It's a completely trustless, completely math-driven consensus.
Let's look at the crucial data structures mediating this whole digital society. The NHF node carries that massive 144-dimension vector, right? While the NHF invite tracks who it was issued to and holds a security signature. But crucially, the NHF receipt confirms the transaction and is etched with its very own unique flame sigil, meaning every single interaction produces a brand new cryptographic artifact.
So the crucial point here really comes together in the demo.c file. This is where the entire bottom-up pipeline seamlessly unites into one native execution path. We see the joules initialized, the ticks applied, the Permute Dragon producing the flame sigil, emergence unpacking all those physical traits, and finally the node joining the Hive Federation, all happening in just a few elegant lines of C code. The whole shebang, right there.
Which leaves us with a pretty profound question to end on. How does a simple 16-bit word, guided by the golden ratio and SA-256, unlock infinite, decentralized complexity? I mean, it's an incredible testament to the power of pure math and strict procedural rules synthesizing a breathtaking digital organism. Think about how these basic laws of physics compound. What other universes could we build with just a few lines of code? Thanks for joining me on this explainer today. Keep learning, and as always, stay curious.